Energy. Energy is an important part of chemical and physical changes. And so we need to understand how scientists define energy and work. Energy is the capacity to do work. And work is defined as the action of exerting a force through a distance. So in this picture, we've got this construction worker pushing a box. He's exerting a force on the box and moving the box over a distance. That fulfills the scientific definition of work. Okay, when I pick up this remote for the projector, I just did work. Did I get paid specifically to do that? No. We think of work as something that you do that someone gives you money for, right? But in science, it's applying a force across a distance. And energy is the capacity to do work like that. There are different kinds of energy. Kinetic energy and potential energy is probably the most significant categories that we'll look at. Kinetic energy is energy of motion. Potential energy is energy associated either with the position or the composition of an object. So here we have this 10-kilogram weight on the roof of a building. This has high potential energy. It's unstable. It's sitting on the edge there, and if you give it a little nudge, what's going to happen? It's going to fall down. This has high potential energy. As it's falling, its speed increases, its motion increases, and its kinetic energy increases. The faster it goes, the more kinetic energy it has. Where did that kinetic energy come from? It came from the potential energy. The potential energy that was high here becomes lower and lower as it gets closer to the ground. When it hits the ground, it now has low potential energy. It can't fall any farther. What happened to all the kinetic energy? It gets dissipated into heat. Now, this heat dissipation is not something that is, usually it's not enough heat that we would notice that it got hot. But when something hits the ground, the potential energy was turning into kinetic energy, and the kinetic energy gets dissipated as heat energy, or thermal energy. Thermal energy is associated with the temperature of an object. Now remember when we talked about solids, I said that particles in a solid are not actually frozen. They're not still. It's like you guys. You're fidgeting, you're wiggling, you're breathing, you're blinking, etc. So they are moving. Thermal energy is how much those particles are moving. If you heat up a solid, the particles move more. So towards the end of a lecture, the thermal energy of students becomes higher because people get antsy. I've been sitting here for an hour and I don't know how much longer I can take this, right? And so they wiggle. Thank you. They wiggle, and that is thermal energy, the increasing movement of the particles. So when this weight hits the ground, the particles in the weight and the particles in the ground around the weight have an increase in their wiggliness, and that's where the energy went. Law of conservation of energy says that energy is neither created nor destroyed. It can change from one form to another. It can flow from one object to another, but the total quantity of energy is constant. And so, people used to come up with these ideas for these perpetual motion machines. It's not possible, scientifically impossible to have something like that. All of those perpetual motion machines that people came up with had some unobserved or hidden source of energy. Objects that have high potential energy tend to be unstable, like that weight at the top of a building, it tends to be unstable. That's a physical potential energy. Chemical potential energy comes from the forces between the particles within a substance, between the atoms, between the molecules. There's a stored potential energy in the form of a chemical energy. And that's why gasoline can be used to power a car. There's a lot of potential energy in the gasoline. So summarizing, energy is always conserved in physical or chemical changes. You can't make it, you can't destroy it. But systems with high potential energy tend to change in a direction that lowers their potential energy, releasing energy into the surroundings. What happens is that we can take more useful forms of energy, and in transferring them into kinetic energy, we lose some of that energy into the environment as heat or thermal energy. So you take the molecules in the gasoline, which have high potential energy, and you burn the gasoline, and you cause the car to move. But in the process of moving the car, some of that energy is harnessed to do the work, and some of it is released. What happens to the engine of your car after you run it? What happens to the temperature of it? It gets hot, right? That's because some of the energy from the gasoline is wasted as heat energy.